Hello, good morning. Today I am delighted to present to you the outcome of my final year project titled Malaysian Sign Language Classification by Image-Based Hand Gesture using Hybrid Algorithm for Hearing Impaired People. This project focuses on developing a groundbreaking system to address the communication barriers faced by the hearing impaired community. This project focuses on addressing the challenges faced by the hearing impaired community in effectively communicating using Malaysian Sign Language. Currently, there is a lack of automated systems for Msl recognition, which hinders the ability of hearing impaired individuals to communicate with the general population. The objective of this project is to develop a hybrid algorithm that combines image-based hand gesture recognition techniques to accurately detect Msl. By leveraging image processing, feature extraction, and classification techniques, the hybrid approach aims to enhance the accuracy and robustness of Msl detection. The ultimate goal is to provide a reliable and efficient tool for real-time Msl recognition. By enabling hearing-impaired individuals to communicate more effectively, the project seeks to improve their quality of life and promote their inclusion in society. Through the implementation of the hybrid algorithm, this project contributes to the advancement of Msl recognition technology and addresses the specific needs of the hearing impaired community in Malaysia. By leveraging innovative techniques and technologies, the project aims to bridge the communication gap and foster a more inclusive society for all individuals, regardless of their hearing abilities. Next is the problem statement of the project. First one is the lack of reliable and efficient methods for Malaysian Sign Language detection poses significant communication barriers for hearing impaired individuals, hindering their ability to effectively interact and participate in society. Next, current algorithms for Malaysian Sign Language detection exhibit low accuracy, posing challenges in accurately interpreting and understanding the unique gesture and expression of Malaysian Sign Language. This is by Padmanan, 2022. The objective of this project is to investigate the current challenges and limitations in Malaysian Sign Language recognition using single algorithms. Next, to develop a hybrid algorithm by combining multiple algorithms such as k-nearest neighbors, naive Bayes, and random forest to improve Msl recognition accuracy. The last one is to evaluate the performance of the proposed hybrid algorithm. Next is significance of study. The significance is divided into two parts, which is first is hybrid algorithm. The significance of developing a hybrid algorithm for Malaysian Sign Language detection lies in its ability to leverage the strength of multiple machine learning techniques, leading to improved accuracy and robustness in recognizing complex hand gestures. Next is in society. The significance of the study lies in its potential to revolutionize communication for the hearing impaired community in Malaysia by improving the accuracy and efficiency of Malaysian Sign Language detection. The scope of my study focuses on the development of a software application using the Python programming language. I leverage various Python libraries and frameworks such as OpenCV, scikit-learn, and TensorFlow to perform image processing, machine learning, and deep learning tasks. In my implementation, I utilize Python scripts to process the input images, extracting relevant features and preparing the data for classification. I then apply machine learning algorithms like k-nearest neighbor, naive Bayes, and random forest for gesture classifications. These algorithms enable this project to analyze the input images and predict the corresponding sign language gesture. To enhance the accuracy of this Msl detection system, this project explores ensemble methods or voting classifier. By combining the prediction of multiple algorithms, this project can leverage their individual strengths and improve the overall accuracy of the system. Through this study, we aim to demonstrate the effectiveness of Python in developing a software application for Msl detection. By leveraging the power of machine learning algorithms and ensemble techniques, this project strives to provide an accurate and efficient tool for Msl recognition, benefiting the hearing impaired community in their communication and interaction with others. As for the overview of literature review, the study aims to address the communication gap between the deaf community and the general public by leveraging advanced technologies and algorithms for sign language recognition. What is sign language? Sign language is a visual language used by the deaf and hard of hearing communities for communication. It has its own grammar, vocabulary, and linguistic structures and varies from country to country. While the specific of the Malaysian Sign Language, in Malaysia, the primary sign language used by the hearing impaired community in Bahasa Isyarat Malaysia, which became the official sign language in 2008. Sign language recognition involves detecting and interpreting hand gestures, facial expression, and body posture as key elements for accurate recognition. While the meaning of hybrid algorithm is the hybrid algorithm approach combines multiple algorithms such as KNN, naive Bayes, and random forest to improve the accuracy and performance of sign language recognition systems by using ensemble learning. In this part, I will introduce some of the past projects and its limitations. The first project is a real-time Malaysian sign language detection algorithm based on YOLO version 3. These projects have a limitation on accuracy of 63.06% during training and 72% during system development, which the performance and consistency of the detection and identification systems are not very encouraging. Next project is evaluating the efficiency of CBAM ResNet using Malaysian Sign Language. The results of this dynamic science video identification studies utilizing CBAM 3D ResNets within blocks and before classifier reveal an overfitting issues. The third project is sign language recognition system using convolutional neural network and computer visions. The limitation is the sign movement frequently become muddled up and unclear. The next project is Malaysian Sign Language Mobile Learning Application, a recommendation app to communicate with hearing impaired communities. The limitation of this project is the sign detection module only can detect few of the signs, and the percentage of detection accuracy is only in 87%. The fifth project is sign language recognition using deep learning and computer vision. The model does not support background subtraction from the image when the frames are dropped from a video. The model also lacks accuracy with noisy images, and the projects use CNN and CV. The last project is Sign Language Recognition Application SunCat. The highest level of accuracy is achieved when only the amount of light is at a certain level. The touch value should be extended, and the project uses CNN. This is the first part of methodology, which is dataset. The dataset used in the study was the Malaysian Sign Language dataset that has downloaded from Kaggle. It consisted of 23 classes representing alphabets A to Y, excluding J and Z because these both alphabets needs a gesture in the Malaysian Sign Language. Each class contained 500 images, resulting in a total of 11.5k images in the dataset. Next is evaluation. I uses confusion matrix, where it is provided a comprehensive analysis of the classification performance of the hybrid algorithm in accurately predicting Malaysian Sign Language gesture. The confusion matrix is a square matrix that displays the number of true positive, true negative, false positive, and false negative predictions. Each row of the matrix represents the instances in a predicted class, while each column represents the instances in an actual class. Now, let's dive into the flowchart that outlines the various steps in my research process. The first step is data collection, where I obtain the Malaysian Sign Language dataset from Kaggle. This dataset serves as the foundation for this research. Next, we move to data pre-processing, which involves several important steps. Firstly, this project performed data cleaning to remove any inconsistency or errors in the dataset. Then, I resize the images to a standardized format for consistency in this analysis. Additionally, I convert the images from RGB to grayscale to simplify the input and reduce computational complexity. Once the data is pre-processed, I proceed to split the dataset into training and testing subsets. This step is crucial to evaluate the performance of our modules accurately. The training subset will be used to train these models, while the testing subset will assess their performance on unseen data. Then, move on to training the models. We have chosen 3 algorithms, which is k-nearest neighbors, Gaussian, naive Bayes, and random forest tree. Each algorithm has its strengths and weaknesses, and by employing a variety of models, I can leverage the individual capabilities and enhance this overall accuracy. To further improve this algorithm's performance, we employ ensemble learning techniques. This involves combining multiple models to make prediction collectively. By doing so, I can reduce overfitting, increase stability, and improve the overall accuracy of this system. One way to achieve this is through a voting classifier, which is a form of ensemble learning. The voting classifier assigns a confidence score to each class label based on their predictions from individual models. We utilize soft voting, which takes into account the probability scores assigned to each class label, resulting in more robust and reliable predictions. Finally, the project evaluates our results using various performance metrics. These metrics include the receiver operating characteristics curve, which visualizes the trade-off between true positive and false positive rates. Additionally, this project assesses the accuracy, precision, and F1 score to measure the overall effectiveness and precision of our models. As we can see here, the first findings of accuracy of each algorithm for random forest tree, the accuracy only reached 41%, and this is the confusion matrix. Next one is the result of accuracy of each algorithm for Gaussian naive Bayes, where you can see its accuracy only reached 65%, and this is the confusion matrix. And the third one is k-nearest neighbors. The accuracy reached 95%, and this is the confusion matrix. And this is the findings for accuracy of the proposed hybrid algorithm, where, as you can see, the accuracy is 97%, and this is the confusion matrix. This is a comparative analysis where the table shows that compare all the results together. And the first one is random forest. As you can see, the individual algorithm for random forest reached the accuracy of 41%, and precision is 51%, recall 41%, and F1 score 39%. As you can see below there, I provide the graph for ROC. The next one is naive Bayes, where the accuracy is 65% alone, and the precision 78%, recall 65%, and the F1 score 65% for the naive Bayes. Next one is KNN. The accuracy is higher than the other two, which is 95%. The precision is 51%, recall 41%, and F1 score is 39%. And the last one is my proposed hybrid algorithm, where I combine all together the three algorithms. The accuracy reached 97%, and the precision is 96%, recall 96%, and F1 score is 96%, where the hybrid algorithm results is better than the three alone. In summary, the project aims to develop an advanced system for Malaysian Sign Language detection using image-based hand gesture recognition. The study focuses on overcoming the communication barriers faced by the hearing-impaired community by providing an automated and accurate Msl recognition tool. Through the use of hybrid algorithm that combines multiple machine learning techniques, including k-nearest neighbor, naive Bayes, and support vector machines, the system achieves a significantly higher accuracy of 97%. This improvement is compared to the individual algorithms, where random forest achieve 41%, NB achieve 65%, and KNN achieve 95%. The accuracy of the system is validated through comprehensive evaluation metrics such as confusion matrix, F1 score, and precision. The proposed system demonstrates its potential to enhance communication and inclusivity for the hearing-impaired community, providing a reliable and efficient solution for Msl recognition. As for my future work, I would like to introduce integration of hybrid algorithm into computer vision for real-time hand gesture recognition and sign language translation. The future work involves the integration of the developed hybrid algorithm into a computer vision system for real-time hand gesture recognition and sign language translation. By leveraging computer vision techniques and the power of the hybrid algorithm, the system will be able to interpret hand gesture captured by a camera and provide real-time translation of sign language into spoken or written language. This will facilitate communication between hearing-impaired individuals and the general public, bridging the communication gap and enhancing accessibility for the deaf community. The system holds promise for application in various domains, including education, healthcare, and everyday communication. As a closure, I would like to state my achievement for this FYP2. The development of hybrid algorithm combining k-nearest neighbor, naive Bayes, and random forest classifiers for sign language recognition. Second one is achieving high accuracy in recognizing and interpreting hand gesture of the Malaysian Sign Language with the hybrid algorithm. Third one is validation of the hybrid algorithm effectiveness through extensive testing and evaluation on a dataset of 23 sign language classes with 500 images each. And the last one is comparison of the performance of the hybrid algorithm with individuals classifier, demonstrating the superiority of the assembled approach in terms of accuracy and robustness. This is my references. And that's all from me. Thank you.